All right, ladies and gentlemen, it is time to do section 5.4, number 2. Once again, that is section 5.4, problem number 2. Now, this problem involves a kind of an interesting situation. We're trying to figure out how long it would take you to go from 0 to 60 in your car. Now, you can look that up. We have looked that up. How long does it take to go 0 to 60 in your car? But we're making it a little bit different because instead of your car going to 0 to 60 using the power of its own wheels, you will be going Flintstone style, so with your feet. These are feet, by the way. So, Flintstone style, how fast, or rather how long, is it going to take you to go from 0 to 60? Now, 60, which is your max velocity, is 26.8 meters per second. So we're going from 0 to 26.8 meters per second. That's what we're trying to figure out. We're trying to figure out how fast you're going to accelerate there. Now, you'd be very tempted to use Newton's second law. F equals ma. But in this case, you don't actually have the force. We have your power, but we don't have the force. And do you know how to change power to force? Well, that's next chapter. Right now, you don't know how to do it. So, how do you figure this out? Well, let's start out with this. Your car is going to have a max velocity. When it's moving, you're going to have kinetic energy. Your kinetic energy is going to be equal to 1/2 mv squared. Now this is where the power comes in. Remember, power is the rate at which work is done. Work divided by time. Or, it's the rate at which work is done, or the rate at which energy is transferred. In this case, you're transferring energy. You're there, in there, with really big feet. You're transferring energy to your car from your feet. You can transfer it at the rate that you produce power. We already did that. So how long would it take you to get here? Well, first off, let's find out how fast we're going here. So, let's find out how much energy we're talking about. So kinetic energy is equal to 1/2 the mass. My car, economy electric car, comes in at 1,567 kilograms. Your car, if it's an economy car, will probably be about the same range. If you got something bigger, like an Expedition or an Explorer, Suburban, something like that, you're going to have a bigger number. My velocity is 26.8 meters per second, and that's going to be squared. Okay, let's keep working here. So the total kinetic energy we're going to end up with, 1/2 of that, I have it already written down, is 7. Silly me. 783.5. Well, that'd be kilograms. We're not going to worry about the units at this point. Times. Now, 26.8 squared is 718.24. Now, if you're doing this along with me, one of these numbers is going to be the same as what I have, and one of these numbers is going to be different. And I'm hoping you found that the first number is different because your car is different mass. Start out with a different number here, have a different number here. This 26.8 squared is going to be the same. You're going the same speed. You're getting up to 60 miles an hour or 60 miles an hour, no matter who you are. Come on in. You can come in. Well, already. All right, so we're going to multiply this together and see what we get. So the total kinetic energy that my car has at 60 miles an hour comes in at 562,741 joules of kinetic energy. 500,000 joules. Your car, if it's bigger than mine, you're going to get a bigger number. So, we now know how much work we have to do, how much energy we have to transfer. You also know the power from when we did our power activity. Let's put them together and see if we can find the time. So, if you want to rearrange this, now you can rearrange this. A lot of people like to use the circle. Circles are very handy. So, for the circle, power is work over time. But if you're trying to find time, it's work divided by power. So, we're simply taking that. By the way, is this a different formula? No, it's the same formula. We just simply are rearranging the exact same formula. So it's work over power. Now in our case, the total work that was being done is equal to 562,741 joules. Divide that by your power. My power was 910 watts. By the way, your power is going to be different. Unless you're as big as me and as fast on your feet, you're not going to have a number that big for power. So it's whatever your number for power is. Now, if I divide these two together, you go down and you find out your time is, well, my time is equal to 618 seconds, which is roughly a little more than 10 minutes for me to move my feet and get myself up to 60 miles an hour. Now, this would never happen in reality because you'd have wind resistance, you'd have friction. I'd never be able to get the car going to this speed. But if you take those out, this is how long it would take me to get there. Now, thinking about numbers, your number is probably going to be bigger. Unless you're driving a very small car like I am, the amount of energy you have at 60 miles an hour is going to be greater. And unless you're as big as I am, your power is probably going to be smaller. So when you divide a larger number by a smaller number, your product is going to be a considerably larger number. So probably you're going to get a lot more than this. By the way, you can leave it in seconds form. That is fine. I just wanted to put this in the minutes form to give you an idea how long it would take you to get to this speed. If you have any questions, let me know. Thank you very much.